If you drove through the rural South 100 years ago, you'd have seen it on nearly every farm, every homestead, every small town lot. A house split clean in half, two separate living quarters joined by a single open-air hallway running straight through the middle. This is the story of a vanishing house design that beat the heat without electricity, one so effective that families inside it stayed cooler through brutal southern summers than most of us do today, in sealed homes with central air. No walls in that hallway, no windows, no electricity. Yet independent building surveys found that airflow through its central breezeway could make interior spaces feel 10 to 15 degrees Fahrenheit cooler than a standard enclosed floor plan, without a single fan, compressor, or watt of power. If this design worked that well, why does almost nobody build one anymore? And is there a version of it we could still use today? The answer involves physics, economics, and a slow cultural erasure most people never hear about. It's called a dog-trot house. It wasn't a stylistic choice. It was a survival response to a climate problem that had no mechanical solution yet. Long before the electric fan or window unit, builders in hot, humid regions faced a puzzle architects had wrestled with for millennia. How do you keep a structure livable when the outside air is thick, still, and unbearable? The earliest ancestors of this idea go back further than you'd expect. In West Africa, traditional compound housing used open central courtyards to funnel air between sleeping and cooking structures. Scottish and Irish settlers brought their own version, the butt and bend cottage, with its separated cross-ventilated rooms, into the Appalachian frontier. When these traditions collided with the punishing heat of the American South in the 1700s, something new emerged. Settlers began building two log cabins a few feet apart, then roofing over the gap to create a shared shaded corridor. That corridor did more than connect two rooms. It became the coolest place on the entire property, and for a long time, nobody fully understood why. By the early 1800s, the layout had a name, and it had spread across Tennessee, Georgia, Alabama, and the Carolinas. One side was for sleeping, the other for cooking, deliberately keeping heat-generating chores away from where people rested. But the hallway between them wasn't just a walkway, it was the engine of the entire house. If you're into videos that dig into forgotten design and how things actually work, this is a good moment to subscribe, since there's a lot more of this coming. What makes this more than just an old house with a hole in the middle is a single piece of physics. Pressure-driven cross-ventilation funneled through a wind tunnel effect. A conventional house with small, scattered windows creates weak, inconsistent airflow because wind has no clear path through. The dog-trot solves this by carving one continuous open channel straight through the building's center. As wind hits the house, it builds higher pressure against the windward wall, while the far side develops a low-pressure wake as air separates and flows past. Air always moves from high pressure to low pressure when given a path, and the breezeway is exactly that path. Because it offers far less resistance than solid walls, wind gets funneled directly into the corridor and speeds up as it passes through. The same principle that accelerates wind squeezed between two city buildings. That's the Venturi effect. Force air through a narrower gap, and its velocity climbs. One detail is easy to miss. The house isn't generating this on its own. It's simply acting as a funnel for a pressure difference the wind already created. As long as the wind blows, the draft keeps flowing. There's a second mechanism hiding underneath the first. Because the breezeway is shaded but open on both ends, it never traps solar heat the way an enclosed room does. The timber inside stays noticeably cooler than the sun-exposed walls, and that gap creates its own convective pull, drawing warm air out of the living quarters and sweeping it through the corridor. The dog trot runs two cooling systems at once: wind-driven ventilation from outside pressure and buoyancy-driven convection from the temperature gap inside. This wasn't folklore. A study by the Vernacular Architecture Forum on surviving 19th century dog trot structures in the southeast found accelerated airflow through the breezeway made conditions feel 8 to 12 degrees Fahrenheit, cooler than outdoor air during peak summer afternoons, not because the air was colder, but because moving air strips heat and moisture off skin far more efficiently than still air. Separate thermal surveys of restored dog trot homes in Alabama recorded interior temperatures up to 10 degrees Fahrenheit below similar homes built without a breezeway. That gap wasn't the dog trot dropping below outdoor temperature. It was the sealed homes trapping heat and climbing above it, while the dog trot's airflow kept rooms close to whatever the outside air was actually doing. The design solved something else too: humidity, stagnant damp. Southern air is exactly where mold, rot, and airborne illness thrive. Constant movement through the corridor kept moisture from settling, which is one reason 19th century physicians often recommended homes be built with a breeze hall for patients recovering from respiratory illness. Long before germ theory was understood, builders had already found a way to flush unhealthy air out of a home using nothing but its shape. So why did a design this effective disappear? It started with one invention: the electric window fan, followed shortly by the residential air conditioner. After World War II, air conditioning went from luxury to expectation, and the need to design around airflow quietly faded with it. If a compressor could cool any shape of house, there was no structural reason to build a clever one. Floor plans flattened into sealed rectangular boxes because the machine, not the architecture, was now doing the work. Economics reinforced it. A dog trot needs more exterior wall and roofline per square foot of usable space than a plain rectangle, since you're essentially building two structures joined by a covered gap. In an era of fast, cheap suburban development, that breezeway stopped looking like the house's best feature and started looking like wasted square footage. Building codes finished the job. Energy codes and insulation standards were written almost entirely around sealed building envelopes, and an open corridor doesn't fit that model. Inspectors see it as an uncontrolled thermal breach, not a deliberate design. Convincing a modern code office that a gap through your house is a feature is a much harder conversation than installing a mechanical system everyone already trusts. There's a cultural piece too. As central air became a symbol of modern comfort, the dog trot got rebranded as a marker of rural poverty, something to renovate away rather than preserve. Many surviving dog trots were modernized by sealing the breezeway shut, permanently destroying the one feature that made the design work. Whether the idea still works for you depends on your climate. In hot, humid regions, the Gulf Coast, the lower Mississippi Valley, and similar zones, a dog trot-inspired layout still genuinely works, and it doesn't require log construction to pull off. Two enclosed volumes separated by a shaded open corridor aligned with your site's prevailing summer wind can be built into any modern frame. Orientation is everything here. Without wind, there's no draft. For an existing home, a full retrofit rarely makes sense, but the principle still transfers. A detached, open-ended breezeway linking a house to a garage or workshop can recreate a scaled-down version of the same draft. Even a deep, open porch running through the prevailing wind captures part of the effect. In cold or mixed climates, this design stops making sense. An open corridor that cools you in July becomes a serious heat loss problem in January, with no simple way to switch it off for winter. The real lesson isn't to go build a literal dog trot. It's that shape, orientation, and a deliberate path for wind were doing real, measurable cooling work for over a century before electricity entered the picture. And in the right climate, they still can. There's another forgotten invention that quietly solved a problem before vanishing without a trace, and it involves a machine that almost changed the world. That's coming up next.